Ice cores are, if you look at the situation globally, one of the best repositories of information about past climates and past environments. And they certainly give records at much higher resolution than deep sea sediments, for instance, which is the other place that people usually go for these kinds of records. So there's a lot to be learned from those records. The other thing is that because of climate warming, those records are being eroded and they're disappearing. There is a collection there that's been assembled over 40 odd years. There was a risk that it was just going to get thrown out into a parking lot and melted, and we wanted to make sure that that didn't happen, because the techniques that are available for analysing ice cores and the range of information that can be extracted from them now are radically different from what existed at the time when the cores were collected. And we also want to develop the capability to generate new cores to look at a new generation of problems. And I think one of the ones that is of particular interest is the issue that we call legacy contaminants, and that is that there's a lot of pollutants which are transmitted through the atmosphere and which are scavenged from the atmosphere by snowfall, and they accumulate on and in glaciers. And so there's a record of the deposition of these pollutants in the ice. But not much attention is being paid to the fact that this is a reservoir of material that's often toxic in many ways, which at some point is going to come out again and back into the water supply, and will have impacts on human populations potentially, and also animal populations. We want to get a handle on what pollutants are there, in what sort of quantities, and what's the likelihood and the timescale on which they're going to come back.